So I have a story to share with you guys. It's going to take me about 30 minutes to tell you, so please just settle in. So about a year ago, I had a visitor from Greece. He got in contact with me through the forum. He was going to be down in my area and was interested in coming and seeing my shop and seeing my work. And at this time, June 13th, our baby with my wife, she was 1 month old, so I was just starting to go back to the shop, but it worked out. I was going to be on the Saturday that he was going to be in town, so we went to the shop and he came by. This is him. He requested a selfie, so we took a selfie. His name is Pascal. He's a lovely guy. He brought a really beautiful Shiraz that he has, and we played some music and we went out to lunch. So when we were out to lunch, there was something on his phone that he really wanted to show me, and it took a couple minutes for it to load up, and I was patient and waited because it seemed like he had to show me. So he showed me a clip from the show Mythbusters. For those of you who are not familiar with Mythbusters, it's a TV show that has two hosts, and they try to prove or disprove general myths. And so he pulled up this little snippet, so I have it here. So I'm going to show you what he showed me. This is maybe a 30-second clip.
Pressure forming technique called hydroforming, and I had never done it before, which was why it was so exciting. I sort of worked my way into it on this episode, and it's a beautiful technique.
There's this really cool bit when we were first testing it out. Jamie was bolting stuff together and pressurizing these halves of steel, and at one point it burst. And we had watched it burst, and then we pulled it out of its frame, and we had it sitting on the ground, and we were looking at it.
What? Like, what? Like, okay, like, right, it's the Mythbusters. They're professionals, but like, what? Like, I was like, that was a time lapse, but it wasn't that long, and like, that metal moved. And at this point, I had a pretty intimate knowledge of what it took to move that metal, and yeah, so I was like, oh, okay, I see why this was very important for you to show me this. And so we talked a little bit about it, but then Pascal left and he went back home to Greece. And so for the next month or so, this conversation continued via email. We went back and forth, and essentially I said, Pascal, I said, like, why should I not do this? Why are we not using this? So we kind of started having this discussion, just theoretically, big picture. Could it work? Could I get it to work? I mean, they're the Mythbusters, like, they're professionals. That's what they do, and they have a lot of support. But could this work? So we started looking at some designs. So the Mythbusters were making kind of like a big teardrop, which I don't need that shape. I just need it to be a circle. So we started looking at designs. This was an initial design that we scrapped. This is something else we also scrapped. And so the first problem that I ran into was I know a lot about the steel that I use for these instruments, and I know how hard it is and how much it can stretch, but nowhere on that little sheet of info does it say how much water pressure I'm going to need to bend it. And this was kind of a stopping point, because if I was going to make something to hold this kind of pressure, I needed to know how much pressure I was going to use. So you might see the conundrum. It was a bit of chicken and the egg. So Pascal had this great idea. He looked up industrial pipe flange safety specifications. What that means to the average person is, imagine a big pipe and imagine the cap that you would put on the end of that pipe. And there's lots of rules about if you have so much pressure in a pipe of such diameter, this is how thick that cap should be, this is how many bolts you should use to hold it, this is how big the bolts should be. So we looked at that and kind of tried to overshoot in terms of safety. So the final design looks something like this. So these are 1.5" plates, 24 1.5" thick bolts, and although you can't see it, there's a plate, and then the second plate has a ring. So there's a main plate and a ring plate. So this is kind of where we landed. So about, I don't know, a month after that, July 12th, I did my last hand-sunk shell. I did not know it at the time, although I did take a picture. This was the process I was starting to like mentally commit to this idea. So I thought, this could be my last shell. So there it is. So this takes us to HOUSA of last year, which is kind of the full circle idea that I got an email from the fabricators I was working with saying, these are the final designs. If you say that you approve, we will start cutting them. And this was that moment where things went from being theoretical to being very real. And I was sitting on one of those porches, looked it over, everything looked good. I took a deep breath, hit send, and committed. So I get back from HOUSA, and it's time to start ordering and collecting parts. There were some obvious ones. We designed those bolts into the system, so I ordered those bolts. But I knew they were 1.5 inches thick. I knew they were 6 inches long. But when they showed up and I actually picked it up, that things got real, because there was 24 of those. Like that's a big boy bolt. So, and there was other things. I made a stand that the plates would rest on, and in this picture, I redesigned the stand, I don't know, 4 or 5 times, but also, okay, there's the hoses, and then this is the main component. So I ordered a pressure washer, and this is the pressure washer that I use. Amazon Prime Special, made of plastic, plugs into the wall, nothing fancy. But pressure washers are funny little machines. They're really powerful. So that pressure washer can put out a max of 2,000 psi. But this is where it's different. We're not talking about air pressure. We're talking about water pressure. And water under pressure has very different properties. So a little dinky machine like that can actually pump out a really significant amount of water pressure. So that guy showed up in the mail. And then there was stupid little things that I didn't know I needed it until I needed it. This is a M22 to 3/8 converter. Didn't know I needed it. I finally found it. This meant that I got to remove the gun, the wand that comes with the pressure washer. I got to remove that out of the system, and I could just plug in a high pressure hose straight to the pressure washer. So it was things like that. So that takes us a little forward. So 10 days later, July 24th, I get the call, hey, those plates that you ordered, they're ready. Okay, like, let's go get them. So I have a truck, and they loaded them in my truck. So what you see here, that's the main plate, and actually in the back there, that's the ring plate. So they were able to load it in my truck, no problem. But we had then had a bigger problem. How do I get them out of my truck? Because they weigh a couple hundred pounds each, and they're kind of an awkward shape to try to get out of a truck. So as it turns out, my neighbor across the courtyard, my shop neighbor, is a piano technician. And he has built this big lift that he uses to get piano plates out of pianos. So Lou, who is actually here today, yeah, there he is. Lou, yeah, yay Lou. Lou was kind enough to wheel out his lift, and it went right over my truck. We hoisted up the plates, we dropped them on that big stand, and we just wheeled them right into the shop. So that felt like a good initial win. That was kind of a big hurdle, but we got over it. But I knew that once I got it in my shop, that I was going to be able to move the plates, because in my shop, I have an I-beam that runs the width that has a half-ton slider. So I knew, like, okay, if I can just get them in my shop, I'll be good. And I will tell you that there isn't a day that goes by that Lou is not jealous of my slider in my shop. Right, so once I had them in my shop, I knew that I was going to be able to move them not only along the width of my shop, but up and down. So, okay, we're good. We've got everything. So now, July 24th, I have everything I need in the shop to get started. So it was time to assemble. The first thing to deal with was the plumbing. So again, right, I have removed the wand from the situation. So this is what the plumbing looks like. So we have our garden hose, which goes into the pressure washer. That's standard. Here's that stupid little converter, which now just goes straight to this hose. So the problem was I removed the wand that had that trigger, right? So now I have no control of the pressure. So the idea is I put this little valve system in, and this allows me to control the pressure. So this little valve here is a needle valve, and it's a really sensitive valve. So if I open that valve all the way up, no pressure passes into the system. It just gets bled off and goes into a bucket. But as I start to close that, the pressure will build, and I monitor that because right downstream is a pressure gauge, a manometer. So from there, we go to another hose, and then that goes into the plate. Now, I knew this was coming, and I was really nervous about it. I had never tapped a hole before. For those who don't know what that is, that was me a year ago. So they put a hole in there. That was part of the design, but I needed to screw a hose into there. So you get this little tool, and you put it in that hole, and you just kind of screw it in, and it puts threads in, and then you take it out, and then you can screw a bolt in, or in this case, put a hose in. Not a hard task. But when you're doing it on a plate, that just costs you a lot of money, and it's the first time you've ever done it, and all the pressure is going in right there. Super nerve-wracking. I was successful. I practiced a couple times, sweating, but and I had to do it twice, but so the pressure comes in, and then it can come out if this is open or closed. So that's kind of how the plumbing works. So that took a day or two to kind of get that all connected. So the big problem, I need to keep the pressure in. I had a few ideas of how I was going to do this. So I had a few ideas prepped once everything was together, the plumbing. And I can tell you, for a week straight, every single idea failed. And not only did it failed spectacularly. So the joke is that I had a really close relationship with this mop. So I would make one attempt and I would mop my floor. I would make another attempt and I would mop. It was a week of mop. At the end of that week, you could have eaten Thanksgiving dinner off of that floor. It was so clean. So the problem is I tried everything that I had thought of initially and it all failed. And again, failed miserably, not even close. So this was a problem. And I was getting really frustrated, and I realize now frustration was probably the secondary emotion. Primary emotion was a little bit of fear, particularly fear of failure. At this point, I was a month in, financially committed, and it wasn't working. And that fear started bubbling up in two questions. Question one, can I even do this? And at this point, I was thinking, like, maybe not. But the bigger question was, even if I can get the metal to form this way, is it going to be useful? Can I use it for my application? Can I make an instrument from it? Will it sing? So I was losing sleep over these questions. So July 29th, I had one piece of metal left. All of my solutions to keep the pressure in, which were different types of gaskets and gaskets material, done. So I was leaving the shop, and I had this idea. And it was using the glue that we glue the instruments together with. Now, I know a lot about this glue. I know how strong it is. I know how hard it gets. I know how much it can stretch. So I took one blank of metal and I put a big bead of glue on it. And the goal was not to glue it to anything. The goal was to let that glue dry, and maybe that would be the barrier that would work. So I came in the next day. I loaded the blank, bolted it all together, turned the water on, just to purge the system. This is a really important step. You have to get all of the air out, which just means taking a moment to let all the bubbles in the system rise to the surface and get spit out the hose. And it purged. I closed the valve. I walked as far away in my shop from it as I could. I got over here behind two barrels that were stacked, put my blast shield on, and I turned on the pressure washer. Now, at this point, I had not installed that little control system, so it was just pedal to the metal. And like you saw in the Mythbusters, I was forming up, and I had put a crossbar up to kind of signify when I had reached my desired depth. I had maybe gotten 1 inch of forming. So I turn it on, and it's working. And we pass an inch. This is the furthest I've gotten. We clear the plates, which means we're over 1.5 inches of depth. At this point, starting to lose sense of time. 2 inches. 2.5, tunnel vision sets in, and I'm like peeking in like this, hiding. 3 inches, 3.5, adrenaline spike, heartbeat goes, 4, and I think my goal was 4 3/8, and we're 4 1/4, 4 3/6, and then it hits the crossbar, and I turn it off, and it worked. So this is very exciting, right? I answered that first question. Can I do this? Well, I've done it once. For things like that, it's almost more important for me to be able to do it again. But I've done it once. I can for sure do it again. So this is what I saw. Yeah. So I unbolt everything and open it up, and that's what's there. So all that's left to do to get a shell is you just trim off the excess. And that was the first one. I took that whole thing home and dropped it on the kitchen dinner table and was like, it worked. And my wife, who had been very supportive and tagging along, looked at it, and I'll never forget what she said. She said, it's not that I doubted you or your abilities or your design. I guess I just doubted physics. Of course, I was like, how dare you doubt physics? Doubt me before physics. Physics is perfect. But I got it. Like I understood what she meant. The fact that water pressure, just coming through this one little hole, could form that in that way. And when you touched it, it was perfect. When you looked at it, it was perfect. When you touched it, you couldn't feel any imperfections. So I got curious, like, yes, it formed, but how did it form? What metal moved where? How did it stretch? So I had an idea to look at the stretch distribution. So what I did is I did this. I took a blank, right? So this is a blank piece of metal that has the holes in it, so the bolts go through the holes when it's all bolted together. But I drew a grid on it, 1 inch by 1 inch, loaded it, ran it, and so then this is what came out. So that was encouraging. But this for me really painted a picture of what's happening and where's stretching. And I had the second idea was I was going to cut this shell in half and measure the thickness across the way. But this was good enough for now. This told me what I needed to know. So there's a couple more shots, different angles. There it is out gleaming in the sun. So the last idea was, at this point I was still turning it off when I thought it was at the right height. And that wasn't good enough. So I wanted to remove myself from being the person on the switch. So, right, so this was August 6th. Somewhere between the night of August 6th and the morning of August 7th, I sat up in bed and I had it. I had this idea. And so this is what it is. So the plates are now flipped over and the shell's forming down. So the pressure washer is plugged into a power strip. And the power, yeah, you get it? Yeah, okay, there it is. And the power strips have those little clicky buttons, right? And so I thought, okay, if I could just get that clicky button to get clicked. So then there's this little pin. So when the shell forms, it hits the pin, and the pin hits the clicky button, and it cuts out power to the pressure washer. So it took maybe 2 attempts to calibrate the pin, meaning that I now know that that pin will give me a shell of 4.5 inches of depth every time. And so then once I had one pin calibrated, I just had to either make the pin longer or shorter, and that would give me any shell of any depth. So, and all I have to do is before I turn the machine on, I just switch out the pins, and then that's it. So of everything you're going to see here tonight, I am actually probably most proud of that. So that first question was answered. Can I do this? Yes. But there's still that second one. Will it work for my application? So that was early August. Now we're here in late September. So it took me that long to make enough shells, to have a batch treated, to get them back. We now have a 3.5-month-old, but I have the first completed instrument. So the only video I have is a video that was shot sitting in my pocket while I was playing the instrument, and I had called my wife and daughter to come see the first one. So that's the video, and yeah, here's number 1. Yeah. Oh, thank you. I slept super good that night. So there were things right out of the gates that I was going to need to change to accommodate this new material, but for sure it will sing. So I go into the shop the next day and I say goodbye to my P1. For those who don't know what a P1 is, the P1 is the biggest air hammer that most people use to sink shells by hand. Now, I'm going to show you 2 pictures I took the day that I packed my P1 away, and I feel like it definitely sums up my relationship with this tool. I'd imagine anyone who's used it, it also sums up their relationship. Yeah. So, thumbs up and middle finger. It was a love-hate. But what this meant to me was I'm committing to this in terms of this is what I'm going to be doing from now on. And I mentioned that there were some things that we're going to need to change to accommodate the material, but right out of the gates, it was going to work. So from September to December, it really was just a period of refinement, mainly with the machine, although I was starting to make those changes to accommodate this material. And what did that mean? Optimizing the gasket. So this was the hardest part. Keeping that pressure in. I could keep it in, but other problems were being caused, and it took 3 months of trial and error to get the right thing. So I was still mopping a fair bit. But I didn't care quite as much because it was working. So this was kind of the final solution. So this is the open view of what happened. So we have the bolts, the top plate, and the gasket. And the gasket is just a thin piece of 1/8 inch thick neoprene that's a 1/2 inch wide, and it is glued to the underside of the plate. So when the water comes in, it gets stuck in this ring that's pressed up against this, and that's how I keep the pressure in. So that's what it actually looks in real life, glued to the underside of the top plate. So January, there was one last step I wanted to take. All the shells I had been forming at this point were slightly smaller than 20 inches. But I was curious if I could just get another ring made that would marry up to that same top plate. Could I just make a different diameter shell? So we did this whole thing again where I ordered another ring, this time 21 inches. Lou brought out his lift. We got it in the shop. And now this machine can make 20 inches and 21. And all I had to do was make 2 new pins to adjust for the depth or the height of the shell for these 21-inch shells. So now this machine could do 2 different diameters. And this was the end goal, to have something in my shop that could do 2 diameters and things of different depths. So at Pantasia 2016, I introduced the ether. And I have a sound clip from Pantasia where you're going to hear me sidestep questions. I'm going to answer those questions today, but let's give a listen.
What you're going to see tonight is really a reflection of maybe 8 months of kind of R&D, refinement. I really think like everything changed. I went back to step 1 and said, okay, let's start with step 1, step 2, step 3, and so on. And as a reflection of that work, these instruments have I finally have named my instruments. Before, I'd always kind of just put my name on them. So these instruments and the instruments I'll be making from now on will have the name ether, A-E-T-H-E-R, after the 5th element. And there's a reason for that I'll probably go into at some point, but maybe not tonight. So.
Yeah, so I'm going to go into that now. So I said everything changed. What actually changed, right? I had to accommodate this new material. Most of them were small changes. My dimple size changed. My dimple ratio changed. My dimple tone field ratio changed. My tone field size changed. My tone field ratio changed. How I make my dimples changed. How I make my ports changed. How I glue my instruments changed. Just about everything changed. Small changes. But if you think of the order in which we make these instruments, step 1 is find what raw material you want to use. Step 2, how do you make your shell? And all the other steps come after. So I went back and I changed step 2. So invariably, everything that came after, there was a long, slow, trickle-down effect to accommodate this new material. So I also said I named them ether, A-E-T-H-E-R, after the 5th element. And I wasn't quite ready to talk about it, but the reason is because they're made using all 4 elements. There's earth, which is the steel. There's water, which is the new addition, which is this forming technique. There's air, which is the nitrogen. And there's fire, which comes in the form of the kiln or the torch. So when I realized I was using all 4 elements, my mind wandered to the 5th element. And the classical 5th element, ether, was the space between the stars, the air the gods would breathe, the root word of the word ethereal, and this felt like a nice fit. So that's why ether. So March of 2016, Pantheon Steel comes to visit. This was like NASA coming to visit. That's what it felt like. They don't visit you, you go visit them. So I will say that I was pretty quiet about this project, but once it got working, and it was working consistently, it was faster than Pantheon's machine, and I wanted to rub that in. So yeah, I rubbed that in, and they expressed some interest in seeing how I was doing this, and so they wanted to come see it in person. So Pantheon Steel comes to visit. Now, this moment, I didn't witness. I was off blabbing in another room with Kyle. But in this moment, Jim had a quiet moment with the machine and looked it over, and somebody got a picture of him. So needless to say that this moment was one that was very special to me, that Jim was interested in my machine. So right after this, you can see that the bolts are in. It's all loaded to go. So we all sat down, and I ran a shell, and it worked, thankfully. And I unbolted it. And so when I unbolt it, there's just a dish of water, and I have to siphon that water out. And so we had a chance to then look at the shell we just saw formed. And this is what Kyle said. He said, "You have harnessed physics in such a way that the metal has no choice but to be perfect." Yeah. So this brought me back to that comment my wife made about doubting physics. I feel like this is the same comment in a way. Yeah, the idea that physics is something that works, and it works every time. And because it's even pressure across the entire surface, the metal just has to take it, and it has to form based on the pressure it's receiving. So I think that was maybe the most elegant way to put it, was what Kyle said. So I've been doing a lot of talking. Do you guys want to see it make a shell? Yeah, okay. So I should tell you just a few things about what you're going to see. This is a 21-inch diameter shell. So pretty standard size. My size, symphonic steel, Syrahs, a lot of us do this size. 18 gauge steel, what that means to common folk is on the thicker side for the industry, but thick standard. It's going to go 5 inches deep. Again, this is pretty deep for this diameter, but this is what I use for my bottom shells. Actual runtime, in the video you're going to see 6 minutes. So when I turn it on to when it turns itself off, 6 minutes. But for the sake of time, I compressed it to 2 minutes. It's also a little more exciting. Now, here's that big question that I struggled with in the very beginning. How much pressure? 350 psi. Now, that might seem a lot, but remember that little compressor, that little water pressure, 2,000 psi. So the 350 is actually not what concerns me. It's the psi, right? Pounds per square inch. Now remember, this is a 21-inch diameter shell. Okay, so pi r squared, it turns out to be around a little over 300 square inches. Now, each one of those square inches is getting 350. So suddenly the numbers get really big really quick. So the final forming pressure is actually, within the system, is closer to 60 tons of pressure. Pretty happy I got those big bolts. So what you're going to be looking at is you're going to be a slightly under view of the shell, and it's going to form down, and it's going to hit that button and turn it off. Now, I did the same thing. Just for you guys, I drew a grid on this so you get to see it form and stretch. Ready? Okay. So I'm off to the side. At this point, I now have that needle valve and the pressure gauge, and I have a time range that I do it in and safety precautions to make sure it works. What you're hearing is the pressure washer. And so we're looking right here, and it might be hard to see on the projector, but this is going to be what's forming, and it's coming down right now. Lou was the first person to see it form a shell. I formed one, and it turned itself off, and he looked at me and he goes, "Well, that was casual." I said, "Well, that's the point, Lou." Right, so here we are. We're probably at 3.5 inches of depth, probably closing in on 200 to 250 psi. The pressure's growing as we're going. And right, so here we are. Here's the pin, and that's going to hit that little switch. So we're still 1.5 inches off the pin. Okay, we're about 1 inch away, probably at 300 psi. You want to go? Can you go to the car and get the box in the back, get the shell? Should we do that out here? In the very back. All right, we're almost on the button. Hit the switch. That's it. So we're done. So real time, 6 minutes. Thank you. This is actually watching it form is great, but this is actually my favorite part. I've unbolted it, I siphon the water out, and I'm going to lift the shell out, dump the water out, and turn it over, and you can see the actual shell that just formed. Okay, dumping the rest of the water out. No more mopping. Yeah, so there it is. So, that's okay. Advantages of this system. In-house production of shells. This means you as a company are not dependent on anyone else to make your shells. It comes with a little bit of responsibility, but it also comes with a great deal of freedom. Perfect, repeatable results. It's physics. Works every time. Also, if you do something like my switch system, it encourages that your shell is the same every time. So, ability to change depth, material thickness, and even diameter. Thinnest I did was 0.95 mil. Thickest I did was 1.4. I still stick with 1.2, but yeah, I can do that. So that's, for those who don't know, that's thicker than the Halo. It's a fraction of the investment of other methods. If I was to do this again, I could probably do it from somewhere between $5,000 to $7,000 to make that machine to do what you just saw. And most importantly, it eliminates the wear and tear of making shells by hand. At the end of it all, I think I made, I think they're in my backpack. At the end of the day, I think I made 150 shells by hand. And for me, I'm big. I'm the right type of body type to be sinking shells, and I can tell you it was not sustainable. And I was talking with some other young makers about this kind of vicious cycle of being a young maker. It's hard to have enough money to invest, to get yourself off the ground, to invest in other shell making methods. So hopefully the accessibility and the simplicity of this type of machine will allow those younger makers to get off the ground quicker and faster and not have these repetitive stress injuries. So why am I showing this to you? To share. So I thought a lot about this, and the final idea was this is to be shared. I would imagine that if you're in this room right now, you believe what I believe, that these instruments make this world a better place. So my hopes in sharing this is that people will take it and make more instruments. And just maybe from sharing this, the world will be just a little bit better. Thank you.